How to calculate derivatives. What do we got? Okay, we have the limit definition. We have power rule, product, quotient. What else?
Rates of change.
We did study rates of change, so that's more of a contextual, right?
Exponential.
We've done exponentials and
Higher derivative.
we did do higher derivatives as well. So that's more. Good. Okay, so
How many known rules and ways are there?
okay, the chain rule combines a lot of these together, right? So we're going to take all of this and we're going to put it into using several of them in one derivative. All right. So the chain rule is a combination of any used together in one derivative. Okay. So we would use the chain rule so we're chaining them together, right? You're locking them together in a continuous chain. That's what we call the chain rule. Do you remember composed functions? Composition of function? If I gave you f of x is x squared and g of x is sine x, right? F of g of x is equal to what? Yeah. Right? That's what the chain rule is for. So we would have to use two different rules here. Oh, we forgot trig. Okay. So to calculate the derivative of this, we have to use the power rule, and we also have to use the trig derivatives, because there are two functions there, right? 1, 2. Okay. Quick note, algebraically, these are the same thing. Remember that? Okay. All right. Good so far? Mm-hmm. Okay, so the chain rule. Let's do that one on right there. We'll start with an example, then we'll kind of give you the formal definition. There's a certain order. It's just kind of an algorithm, kind of like the product rule and the quotient rule. There's a certain way you have to do it. Okay. So the key here is the first. So identify the most. The outer most function. Oh, don't bust my chops. I almost made a slip up there and owed you guys candy bars or something. So if I went back to this function, if we rewrote it like we had it, what's the outermost function? It's squared, right? Yeah, so we're going to start with the power rule. Okay, so derive this first. Okay, so what's the power rule? When we write this out. It will not be that clunky every time, okay? But I gotta keep stressing it to you when I pick your homework up. About half of you are not writing this notation. You're not gonna get the credit. Okay? All right, so what's the power rule? So if I were to derive just the x squared, right? What would that be? 2x, okay? So 2. What was inside of that? Sin x. Okay. So we've just done the power rule. Okay, on the outer functions. And then we also have to derive the inside function. We call that the inside. What's the derivative of sin x? Sin x. See how that works? So pick on the outside function first. Then you just copy the inside, just leave it alone. And then you derive the inside function. Okay. See if you can handle that. That's the chain rule. Now I can get awfully nasty, of course, because we like to do that in math. You remember when we wrote our memory cards, we had this little, do you remember the acronym or whatever we used? That was the quotient rule, right? We have that for the quotient rule. Low D high minus high D low to square what's below. So we have this. Yeah. So if you want to remember it this way, you can. But derive outside. Copy inside. That would be this. And then derive inside. Right?
So for that example, you would just do it like that?
That's your answer.
Okay.
You can't do anything with it. There's no algebra to simplify it.
So you leave the sin x.
Mm-hmm. Yeah, because that's your inside function. Right. You just copy it the first time through. You do one derivative at a time. That's the idea. Okay? So if I'm going to use the power rule, I do the power rule, everything else stays the same. Okay? But then I can mess with everything else. But just do one thing at a time. Okay? That's a big key here. Just do one derivative at. Okay, big deal. Any questions on this? Formally, if you look in your book, this is what the derivative will look like if you're just using function notation. If I want to derive this composed function, what's the outer? Yeah, f. So we do f prime, right? Derivative out. What do I do with the inside? Which is d of x. And then keep my theme here. And then what? Drive inside, right? So derive outside, copy in, derive inside. Okay. just run through a few examples. What if you are given this It's fine, don't erase it. I'm just writing in a different color to stay consistent.
Would the cosine be the outside?
Yeah, now the cosine is your outside function.
So whichever end is there always going to be parentheses?
No,
So how do you know which one's inside and which one's outside?
you have to be a mathematical thinker. I'll show you. Okay. So, derive outside, right? What's the derivative of cosine? Negative sine. What do we do with the x cubed? Derive outside.
Copy.
Copy, don't psi, right? Copy inside. Now what? Derive inside.
We put it on the outside of it?
Yep. Those do not go together. They are separate. So derive out, copy in, derive in.
So we then got sine squared x. That becomes 2 sine x. Then that be that times cosine x at that point too.
Yeah. 2 sine x, cosine x. Yeah. Questions on this one? Okay. All right, let's try one that's a little bit. Okay, calculate the derivative of the square root of x to the fourth plus 1. How do we, so rewrite roots, right? How do you rewrite a root? So it's this is the same as the derivative of that function, right? Same thing. You notice that my statements still keep the d over dx, because I have not derived this yet, so I have to keep it if I write an equal sign. What's the outer function? Yeah, and your power. So the power rule. And what do I do with the inside? Copy it down. And then derive the inside. So we're chaining these rules together. We have the power rule twice here, right? Just use the power rule twice. They've chained 2 power rules together. Okay. On the first one here, you chain together a trig function and a power rule. So that function on a multiple choice exam will not be written like that. Can you simplify that algebraically?
What do you have to do?
Boil it.
Nope, it's easier than that even. What's on top, this is a negative, so what does that mean?
1 over.
So the root, this is the square root, goes on the bottom, right? There's also a 2 in the bottom. And the 4x cubed, top or bottom?
Top.
Get used to doing that. Okay? Get used to rewriting those. It cleans them up.
Why do you multiply by 2.
Now, could you cancel a 2 out?
Yeah.
But where did that 2 come from?
1/2.
1/2.
Uh,
So, these questions also come a lot of times with where is a horizontal tangent line?
so you take 0.
So you said set equal to 0, right? It's a fraction. Do I even need to worry about top or bottom? Is there one I can just wish away? If a fraction's 0,
You have this at the top.
the top is the only thing you worry about, right? You don't need to worry about that. Because the fraction is 0 as the top, numerator is 0. So what does x equal? It's really easy.
0.
0. This is a horizontal tangent line at x equals 0. Okay. What else could I ask on this question? Yeah, you could also do a vertical tangent line. What do I need to set equal to 0 for a vertical tangent line?
With all
Yeah, the denominator now, because the slope is undefined. Vertical slope is undefined, so set the bottom equal to 0. Right? And solve. What do you get? Square it, right? Subtract 1. Is that possible? Okay. So there's no vertical tangent line. Alright, so be prepared to answer those questions, right? The equation of a tangent line, all the same stuff is going to occur in these problems that we studied. You're just using the chain rule now to calculate your derivatives.
Okay.
Let's look at a more fun one.
Yeah.
I got a fun one. Calculate more fun because you get to do more math. That's what it is, right? All right. What do you think? Outside? Yep. Derivative out. So dy dx is derivative 10. Yep. Secant squared. What do you do with the inside of it? Copy inside. And? Now derive. What do you derive? X over. How do you do that derivative? Yeah, it's a quotient rule problem. Oh, the agony and the pain. So you can do more math. It should be fun. You should be happy. Okay, you hate me right now. Quotient rule. Okay, there were a couple of you that tried to derive this just top, just bottom. Not Good. The quotient rule. Copy the low, d high, or derivative high, minus what? High, then d low, over square of what's below. Most of you have got that, and I'm thrilled. Still a couple of you struggling, that doesn't make me very happy. That's a longer one, right? A little bit more nastiness involved.
That's your
Would
answer?
you need to simplify?
You're probably gonna have to simplify this because the top here can algebraically simplify it.
I don't want to.
You would have negative x
No,
over
it's
x
just
plus
plus
one.
one minus
Yeah, so x plus 1 minus x is,
x plus one minus x over, or x, negative x over x minus one. Can you simplify that one?
x minus x is 0. The 1's left over. Right?
Or could you cancel that x plus one out with a square on the bottom?
No. The only way we could do that is if there's an x plus 1 over here. Then there's 1 in every term.
Okay.
No, we can't cancel an x plus 1 out because there's not one here. Okay, good question. I think a lot of people were thinking it. That's as simple as it gets. You're done, though. Okay? Yeah. Let's try that one. Okay, there's another function. This one's involving e. Which one's the outside function?
I guess there's a b.
The x
It's an exponential.
I think this is wouldn't it be cosine of t?
No, it's not. It's a common mistake with this one. The e is the outside function. It's e to the x, right? And what's put inside e to the x? Cosine. So you have to think of it as cosine's put inside e to the x. Right? So the outside function is actually the function e to the x. All right, so what's the derivative of e to the x?
E to the x?
Yep. And what do I do with the inside? Copy. And then the outside, what's the derivative of cosine? Inside. You're going to get really good at that. And it is not in the exponent, it is down below in the normal spot. Okay, so keep that in mind when you get to e to the x exponentials, that the outside function is the exponential. You're putting something inside of that.
You did derive outside class.
Good. Thank you. Yeah. Go. Literally. There we go. Better. Those are basic chain rule problems. Think you can handle them? A lot of you are shaking your head, yes? Okay. If not, it's day one. We'll get better. Okay. We'll get better. See why we want to have a handle on the power rule, the product rule, the quotient rule, and the trig functions already?
So the derivative of e is just e.
Derivative of e to the x is
E to the x.
the x.
Gotcha.
Okay, do you remember what the derivative of 2 to the x is?
X squared.
Or no?
Somebody's doing their memory cards. These are the same derivative, but the L, what's the natural log of e? Natural log of e is 1. That's why we don't have anything out front. They're both exponentials, right? But the natural log of e is 1. So ln e, e to the x, ln 2, 2 to the x. They're the same thing. You just have a 1 there. All right. We're going to do some more of these, a little more difficult on Tuesday, and do some practice. If you are someone that doesn't like the cold, you might want to bring a jacket because we're going outside. Wiping a fake tear away. Again, there are a lot of basic problems here, and there are some challenging ones. Okay? So if you're struggling with derivatives, focus on the basic problems. If you're good, give them a shot. And I'll put some other spiraling in there. Okay. The more practice you get with the stuff you already know, the better. You've probably got, let's see, 3/8 derivatives of inverses. 3/9, I can't remember what it is. 3/10 implicit diff, that's 2 days. Related rates, 2 days. You've probably got about 2 weeks before the other test. Okay? Don't wait till the last minute to practice, because it's not going to happen. Right? Chain rule.